In this video, we're going to talk about cross product of vectors. And as you can see from this arrow, the cross product of two vectors will also be a vector. And how will we get the direction and magnitude? Let's figure that out. For direction, we'll use our right hand. If we have two vectors, the blue vector and the green vector, and we want to find the direction of the cross product of these two, we can use our right hand to get the direction of the cross product, the yellow vector. So how do we do that? Well, if you're taking the product from blue to green, you're moving from blue to green. So if your fingers move from blue to green, your thumb will point towards the yellow vector, the cross product. If this is A vector and this is B vector, this yellow vector will be A vector cross B vector in the direction of the thumb. And what's the formula for this? Well, A vector cross B vector, that's equal to mod of A vector times mod of B vector times sine of theta. Theta is the angle between A and B, moving from A to B, times, and here's the fourth quantity, n cap. N cap is the unit vector which is perpendicular to both A and B. So this has four parts. Let's break all of them down. This one, n cap, that's the unit vector perpendicular to both A vector and B vector. You get this direction from right hand thumb rule. This theta is the angle measured from A to B. So the direction is important here. You're moving from A to B. So A cross B. So this is how you get theta. These two are the magnitudes of A vector and B vector. So if you combine all of them, you have magnitude, some number, but some vector. So something real times a vector. So this makes this cross product a vector. Now, one important thing about this angle theta, this theta ranges from 0 to pi. 0 is when A and B overlap, and pi is when A and B are facing the opposite direction. We usually don't take a negative value of theta. If A and B switch places, for example, if A is here and B is here, now if you move from A to B, you move in this direction. So the theta is still positive, but your thumb is now pointing downwards, and this will give us the opposite direction of what we got in the previous case. All right. Now let's ask the same questions that we asked with the dot product. Let's understand this formula better. When is this 0 and what happens at other angles? Pause the video, think about it. What happens when this cross product is 0 and what happens for other angles? Okay, let's think about it together. If this is 0, this means some part of this is 0. Mod of A, mod of B, sine theta or n cap. N cap can't be 0, it's a unit vector, it has a magnitude 1. Mod of A and mod of B, either they can be 0, either we're dealing with 0 vectors. And if that's not the case, then sine theta must be 0. And when is sine theta 0? Sine theta is 0 for two angles. Theta is 0 or theta is pi. Theta is 0 means they're facing the same direction. Theta is pi means they're facing the opposite direction. In both the cases, A vector and B vector are collinear. So for collinear vectors, sine theta is 0, which means the cross product is 0. That's a useful result. So when we have a cross product equal to 0, we can say that we're dealing with collinear vectors. Now what happens at other angles? What happens when theta is pi by 2? So sine pi by 2 is 1. This means A cross B, that's equal to mod of A vector times mod of B vector times n cap. Now n cap is the unit vector perpendicular to both A and B. Now let's talk about the unit vectors. What happens for unit vectors? And our classic unit vectors are I cap, j cap and k cap. And all three of them are in fact perpendicular to each other. They are mutually perpendicular vectors. So this angle is 90 degrees, this angle is 90 degrees, and this angle is also 90. So let's take their cross product. Let's take I cross j. That's going to be equal to mod of I times mod of j times sine of the angle between them, that's sine pi by 2, times a unit vector that's perpendicular to both I and j. And we can get that using right hand thumb rule. If you move from I to j, you point towards k. So that's going to be k cap. This is 1, 1, 1 times k cap. So what we get is I cap cross j cap, that's equal to k cap. And we can do this for other combinations as well. I cap cross j cap is k cap. We can see that j cap cross k cap is going to be equal to I cap. If you move from j to k, you can see that your thumb is pointing towards I. Similarly, k cap cross I cap is going to be equal to j cap. If your fingers move from k to I, your thumb points towards j cap. So k cross I is equal to j. And if you move in opposite directions, suppose if you want to find j cross I, that's going to be equal to minus k because you'll be facing down. Your thumb is going to be facing down. Similarly, k cross j is going to be minus I, and then I cross k is going to be equal to minus j. Now these are some useful results, but we don't have to memorize them. You can always get them using the right hand thumb rule. All right, let's talk about collinear vectors. What happens when we take the cross product of I and I? So I cross I, because the angle between them is 0, this is going to be 0. And same is the case for j cross j or k cross k. All of them are equal to 0. And because direction is important, it matters whether you're taking I cross j or j cross I. We can say that b cross a, the opposite of a cross b, that's going to be equal to minus a cross b. So these two are negative of each other.